Good day everyone, I am Hannah M. Daklas from BS ECE-38, and in this video, I will show to you the output of my task number 8 activity, stepper motor control using microcontroller board. And in this activity, we are tasked to combine the 3 videos that we have recorded from the exercises and create a short presentation video of our performance output for this activity. And using the output of exercise number 1, number 2, and number 3. So first, I will show to you the output of my exercise number 1 and exercise number 2. So this is the schematic diagram for my exercise number 3. So as you can see, the stepper motor was already connected to our ULN 2003 driver. And also the input 1 to 4 of my driver is connected to the pin 8 to 11 of my Arduino board. So this is the schematic diagram of my exercise number 3. Now, these are the components used in this activity. So this is the code that I created for my exercise number 3. And on our exercise number 3, we are tasked to make a program for our stepper motor that it will first rotate 90 degrees counterclockwise and it will go to 9 o'clock position on the clock. And then it will rotate 180 degrees clockwise and it will go to 3 o'clock position on the clock. Then it will rotate 270 degrees counterclockwise and it will go to 6 o'clock position on the clock. And also, it will rotate 180 degrees clockwise and it will go to the 12 o'clock direction on the clock, then it will stop. So here on the code that I created, I will explain why I used this series of numbers first. And so here, we will be using a 4-step sequence, and a 4-step sequence has an equivalent of 11.25 degrees. And 1 revolution is equal to 360 degrees. That is why we will divide it by 11.25. And with that, we will have a 32 steps per revolution. And since the ratio of revolution motor shaft to revolution output shaft is 64 to 1, thus we will multiply 64 to 32 and then we will have a 2048 steps per 1 revolution. And since we'll be using a 4-step sequence, so we will divide the 2048 by 4. So we will have a 512 steps for 1 revolution. So as you can see here in this part, I declared pin A that it will be I declared the pin 8 to be our pin A, and pin 9 to be our pin D, pin 10 to be our pin C, and pin 11 to be our pin T. And I just put the delay or motor speed to 3. And now here on our void setup, I declared the pin A to pin D as our outputs. Now for this part of the program, this will be the command that used to make the stepper motor shaft rotate to their specified direction and angle. So first, on the first part of the program, so it will rotate 90 degrees. So since there are 360 degrees for one revolution, so 360 degrees divided by 90 it is equal to 4. And 512 steps divided by 4 is equal to 128. So there will be 128 steps, and it will go counterclockwise. So later on, we will declare what is counterclockwise and clockwise. So next is it will rotate 180 degrees. So 360 degrees divided by 180 is equal to 2. And 1/2 512 is 256. Now, in this part, the motor shaft will rotate 270 degrees counterclockwise, and 360 degrees divided by 270 is equals to 4/3, and 512 divided by 4/3, it is equal to 384. And it will rotate counterclockwise. For the last part, so it will rotate 180 degrees clockwise, and then it will stop. So again, 360 degrees divided by 180, it is equal to 2, and 512 divided by 2 is equals to 256. So that is why these are the series of numbers that I used for my program. So I just put them to the void setup because since the instruction here that after rotating 180 degrees clockwise, and it will go to the position of 12 o'clock, it will stop. So I just put it here to void setup. So once it go to 12 o'clock, it will stop, and there will be no loops. So that is why the void loop here is just blank. Now we will declare here the clockwise and counterclockwise. So for the motor shaft to move clockwise, these are the command that I will be using, and for the counterclockwise, these are the command that I will be using. Now I will just upload this code to our Arduino Uno R3.